Hello, Electrical Circuits Tutorial Series, part number 6, basic or parallel circuit analysis. The math calculations uses Ohm's law and the power formula to gain our expected values to compare as our baseline when we go and make our live readings. So we'll be using a simple 3-branch parallel circuit. R sub 1 is the left, R sub 2 is the center, and R sub 3 is the right. We need to first off trace our circuit, make sure we have more than one path for the current to flow. So here we go, we come to node, we got a path here and a path here, another node, a path here and a path here, to this branch, all the way back to the node where they connect back together, there and there, and back full circle to our power source. So we do have 2 or more paths for the current to flow, so this is a parallel circuit. The values that have been given to us for this circuit will be a total voltage of 120 volts DC, and our individual load resistances, our branch resistances in this case, R sub 1 is 15 ohms, R sub 2 is 10 ohms, R sub 3 is 30 ohms. Now to get started, we're going to have to find the total resistance of this, and for the total resistances, we can use 3 different methods to do it. The first one is resistors of equal value, and each branch would have to be exactly the same resistance, and you'd take the resistance of one branch and divide it by the number of branches. We can't use that here because we have 3 different values for our branches, our resistances. Another method, we could use it here, but it's kind of counterproductive, is the product over sum. It's ideal if you only have 2 branches, because it's the with that third branch or each additional branch, you add calculations, room for error, margin for fat fingering a key on the calculator, and everything. But if we used it, we'd have to do R sub 1 times R sub 2 divided by, open your parenthesis, R sub 1 plus R sub 2, and then that answer would become R sub 1 slash 2, and we'd have to do another product over sum, R sub 1 slash 2 times R sub 3 divided by, open your parenthesis, R sub 1 slash 2 plus R sub 3 to get our total resistance. We're going to use the reciprocal value. Now the product over sum is backwards compatible. You can use it where you could use the resistors of equal value, and the reciprocal formula is what we're going to use. It's a 3D fraction. It's the reciprocal of the reciprocals. It doesn't care how many branches you have, you can do it in one calculation, and and it is also fully backwards compatible to use on resistors of equal value also. So R sub t would be equal to 1 divided by, open your parenthesis, 1 divided by R sub 1 plus 1 divided by R sub 2 plus 1 divided by R sub 3, and close your parenthesis. So we're going to put it down as 1 divided by, open the parenthesis, 1 divided by 15 plus 1 divided by 10 plus 1 divided by 13 to give us a total circuit resistance of 5 ohms. Now our parallel circuit rules for resistance tells us that the total circuit resistance will always be lower than the lowest branch resistance. So our lowest branch resistance would be R2 of 10 ohms, and it is in fact less, so we do follow the rules still. And now we'll find our voltage for the rest of the branches. And if you remember, in a parallel circuit, the voltage remain constant across all branches. So V sub t is equal to V sub 1 is equal to V sub 2 is equal to V sub 3. So in this case it would be 120 volts, and we can populate in the rest of our voltages up there. Now we can go on and find our current. And finding our current, we just simple Ohm's law. And so our I sub t, our current total, is going to be equal to the voltage total divided by the resistance total. So 120 divided by 5 will give us 24 amps total for this current. So I sub 1 is equal to V sub 1 divided by R sub 1. So V sub 1 of 120 volts divided by 15 ohms of R sub 1 will give us 8 amps for that first branch. I sub 2 is equal to V sub 2 divided by R sub 2. So V sub 2 of 120 volts divided by R sub 2 of 10 ohms will give us 12 amps. I sub 3 is equal to V sub 3 divided by R sub 3. So V sub 3 of 120 volts divided by our 30 ohms of R sub 3 will give us 4 amps total. Now we have a quick check that we can use here because the parallel circuit rules state that the sum of the individual branch currents always equals the total current. And so we can add in our 8 amps, our 12 amps, and our 4 amps, and that gives us our 24 amps total. So we did do our math right. Again, that's just a quick check to ensure that you did do the calculations right. And then finally we go to our total power, the wattage for the entire circuit, and the power dissipated by each individual branch. And so P sub t is equal to I sub t times V sub t. So P sub t is equal to 24 amps times 120 volts gives us 2,880. In electricity, we speak metric notation, so we would call that 2.88 kilowatts. P sub 1 is I sub 1 times V sub 1. So I sub 1 is 8 amps. V sub 1 is 120 volts. Multiply them, that would give us 960 watts dissipated by that first branch. P sub 2 is equal to I sub 2 times V sub 2. So 12 amps for I sub 2 and 120 volts for V sub 2. And that would give us 1,440 watts or 1.44 kW. P sub 3 is equal to I sub 3 times V sub 3. And so our 4 amps times our 120 volts would give us 480 watts. Now, the power rule, it applies to series circuit, parallel circuits, combination circuits, and parallel series circuits. And so a quick check we can do, since the sum of the power dissipated by the individual components always equals the total power, we can add up P sub 1, P sub 2, and P sub 3. So we can add 960, 1,440, and 480, and we'll get that same 2,880 watts or 2.88 kW. This concludes the part 6 of our series. I hope you join us for the next. Thank you.